We are in live, ma'am.
Okay, sir.
A very good evening to all, and some countries are good morning now. So uh, now we are connected with us our last keynote speaker, Dr. A. Batmapriya, ma'am, the professor, Department of Computer Science, Alapa University. She is going to be given the topic of keynote on the research prospects in machine learning. She is well versed in the computer science and technologies. Ma'am, now session is yours, ma'am. Please carry on. Thank you,
Thank
ma'am.
you. Thank you for your introduction. Dear participants, first of all, I welcome you all for my session. I'm going to share some of the knowledge gained in the field of machine learning to you all. I would like to thank the organizers for giving me an opportunity to meet you all. Shall we enter into the session? So, the session is about research prospects in machine learning. So this is my agenda. So today I'm going to give you a brief introduction about what is conventional computing and what is intelligence computing, and how far artificial intelligence is influencing the entire world, and depending upon the machine learning as well as the types of machine learning, and what are the present research trends that are going in the field of machine learning. That is the agenda of today's keynote session. So, as we all know, necessity is the mother of invention. And of course, when we are talking about a mother, we used to have an idea about the father. So this is a famous cartoon, so which insists on the father of invention. It is nothing but greed. So without greed, we're not going for any kind of invention. So these two things, with this few words, I'll start this session. So here, inventions. The inventions, it is being categorized into four different industrial revolutions. In the first industrial revolution, we are concentrating only on mechanization. So there, we are making use of steam engines and water power. In the second industrial revolution, we are focusing on mass production. So here we are making use of electrical power and all. So here the target is about mass production. So first stage they are starting the production. Second stage they are going for mass production. Whereas in the third stage, human want to have some kind of sophistication. So what they did is they have gone for automation. That is the Industrial Revolution 3, and in the Industrial Revolution 4, uh, we are entering into the smart mechanisms. So here we are concentrating on smart factory, autonomous systems, IoT, as well as machine learning. So this is what we have gone through four different industrial revolution, and what industry 4.0 is having. So these are the basic components that contributing towards the industry 4.0: data analytics, wireless communication, cloud computing, sensors as well as IoT, and then automation, artificial intelligence, AR and VR, that is augmented reality, as well as virtual reality, 3D printing. So in this session, we are going to concentrate on this subdomain, artificial intelligence. So before entering into the artificial intelligence, we must know what is the difference between conventional computing as well as intelligent computing. So this is what about conventional computing. So in the conventional computing, we'll be giving some data. In order to process the data, we need to write some kind of programs. It will be entered into the machine, and the machine will produce the output. This is what we are doing in a traditional way, that is conventional computing. Whereas what happens in the case of intelligent computing is, so we'll be having the data. With the data, we are having some kind of output based on our previous experience and all. So depending on these two things, we are going to create a model to predict something what is going to happen, or to react upon what is going to happen. So this is what about intelligent computing. So this is the traditional difference between conventional as well as intelligent computing. So in the conventional computing, what we are concentrating on is So we need to follow a logical series of steps. So here, the programmers, they design the software to accomplish the task. So all these things will be done with the help of some kind of algorithms. Here we are focusing only on what to do, how the data will be received or perceived by the receivers. So simply logical series of steps. Let me show you an example for conventional computing. So the picture I'm showing is about a container having water, which is having lot of bubbles. Let me show you the example. So the logic behind bubble sort is this one. So what the bubble sort will do is it will compare two consecutive numbers. If the number is smaller, it will move the number towards the top. So just like a weightless water bubble moving from the bottom towards the top, the bubble sort will sort the numbers from the bottom towards the top. So smallest number will be moved to the top in each and every iteration. So this is what we are concentrating on, conventional computing problems. So just they'll do the assigned job. So we have to give the instructions so the machines will do the task. This is what about conventional computing. Now let me show you what about intelligent computing. So intelligent computing means it is the methodology which has a computing ability, so that is having the ability to learn, deal with the new situation. So it may have one or more attributes. So depending upon the learning capability, it will deal with new kind of situations. So something it is what we normally call this. It is designed to mimic one or more aspects of carbon-based biological intelligence. So just like human, so how we react to real-time problems, the machine is also um, given an ability to learn and deal with the new situations. This is about intelligent computing. So let me show you an example for this intelligent computing problem. So this is a famous game. We all know this game, tic-tac-toe. So here, machines are human will be playing this game. So here, we could not able to predict the opponent will do this kind of move. So depending upon the move, we need to find out the alternate solution, and based upon the move only, we need to make our own move. So here, intelligence is actually required to solve this kind of problems. So this kind sort of problems are called as intelligent computing problems. So, literal meaning of intelligence is it is the ability to learn, understand, and make judgments or have opinions that are based on a reason. So, based upon our learning ability, we must have some reason to choose or make some kind of judgment. That is what we call intelligent. So, here we are having three different kids. So these three kids, they want to participate in a fancy dress competition. So what their parents did is they are somewhat highly intelligent. Okay, so they made an arrangement to put a uh, fancy dress like this. Okay, so here the intelligence is making something new. So need to adapt depending upon the situation. So they are making something new idea. Okay, that is what we call it as intelligence. So, according to Albert Einstein, the measure of intelligence is the ability to change. So, depending upon the changing requirement, we have to make judgments accordingly. So, the intelligence, as far as Albert Einstein is concerned, so the measure of intelligence is the ability to change. And Stephen Hawking's intelligence is the ability to adapt to change. So, based on these two things, the key term artificial intelligence was derived. So John McCarthy, he is the usually recognized as the father of artificial intelligence. He coined the term artificial intelligence in mid 1950s. So as according to him, he defined artificial intelligence as it is the science and engineering of making intelligent machines. So we need to have science aspect as well as engineering aspects to make the computers to think. Okay, so he's called as the father of artificial intelligence. So here The artificial intelligence means it is engineering of making independent or intelligent machines. So for this, we need machine learning. So machine learning, it is having the ability to learn without being explicitly programmed. So what happens in the case of conventional programming is we'll be programming the machine explicitly. Whereas in the case of intelligence computing, so the machine itself learning depending upon the scenarios. And the deep learning, so the learning it is based on the deep neural networks. So this is what actually the boundary of artificial intelligence as well as the machine learning. So artificial intelligence is the upper domain. So within the domain, we'll be having machine intelligence, machine learning. So here, what happens is, so artificial intelligence. So we must have some kind of automation also. Depending upon the learning, we need to go for a virtual automation, and sometimes there may be possibilities of learning something in a wrong way. So we need to have a self correction also. So here, this is where machine learning is taking place, and so this is the one of the famous definition coined by Arthur Somwell. He was the computer gaming and AI pioneer. He gave the definition of for machine learning in the year 1959. Machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. So this is one of the famous definition of machine learning, and uh, without being explicitly programmed. So how we are doing the work? So a computer program is set to learn from its experience. Suppose if you are riding a bicycle, if you are falling down, we used to correct ourselves in which position we are falling down. Just like that, we learn from experiences. Okay, so for any specific task, some kind of experience is required. So to learn from the experience with respect to some class of task. Suppose if our learning is improving means our performance is also improving. So the machine learning, the entire concept of machine learning is this one. So we need to learn to do a task, thereby we have to improve the performance. So the performance at task in T as measured by P, that is the performance, improves with experience. So this is the definition given by Tom Mitchell. So it was in the year 1997. So these are the basic types of machine learning. So when we are speaking about machine learning, it can be categorized into three different types. One is supervised learning, unsupervised learning, and then reinforcement learning. So these are the three different types of machine learning. So supervised learning, it is mainly task driven. Usually it is used to predict some kind of next value. And unsupervised learning is it is data driven. So depending upon the input, we need to go for the knowledge. So it is data driven. So here we'll be identifying the clusters. And the reinforced learning, it is something what we are learning from our mistakes. From our past mistakes, we'll be learning something new. That is about reinforcement learning. And supervised learning. This picture, it gives a clear-cut overview of what supervised learning is. So here what happens is we'll be giving some kind of input. Here your input is the raw data, and here we'll be having the machine learning algorithm. So in order to assess this machine learning algorithm, we'll be having a supervisor. So this supervisor will assist in the learning process. Okay, so here we'll be having the training data. So depending upon the training, we'll be getting the desired output. So all these things will be given for processing, and based upon this thing, we'll be getting the outputs. So here one person will be there for assisting the learning process. So here all the data are said to be labeled, and the purpose is mainly for classification, prediction, and or optimization of the performance. So for example, it can be used for weather conditions. Suppose if today's climate is this, so what will be the climate next week? So what will be the range of temperature? So all these things can be identified with the help of this supervised learning. Let me show you an example for supervised learning. So here there is a supervisor. So this supervisor is telling about something to the robot. So the robot is learning and it is making its own decision and identifying the solution for the problem. Okay. So here these are fruits. Robot is saying okay. So this is apple. Okay. So the person is showing different kinds of apple. After some time, the person has gone. Now, the robot itself is identifying so what it is. So depending upon the learning, it will try to match, and it is identifying that it is an apple. So this is an example for supervised learning. So this is what actually happens. So in supervised learning, you'll be having the data. So the data will be divided into two different options. One is called as training, and the another one is called as a testing. So depending upon the training as well as testing, a model will be created. So using that model, we can able to have some kind of predictions. So this is what we call it as supervised learning. So training data, testing data. Here the model is created, and the model is validated by the test one. It is valid, and once the model is validated, it will be used for new data. So depending upon the new data, we can able to do the predictions. So this is what happens in the case of supervised learning. So this is one kind of example for supervised learning. So imagine this is an image classification. So here we are having an image. Now we are going to justify whether this one is a cat or a dog. So here this input is given. It is given to a deep neural network. So depending upon this, we'll be having two different classes, and the cat is not suitable. So the output is dog. So this is what we call it as an example for image classification using supervised learning. Next, we discuss about unsupervised learning. So here, in the case of unsupervised learning, we don't have any kind of supervisor to assist our algorithm. So here I'll be given input raw data. We need to interpret it. So the data will not be labeled. We need to label it properly. In the earlier case, we'll be having dog, cat, and all. Here it is not like that. There will not be having any kind of label on. So we need to the machine has to learn, and it need to create the labels. So depending upon that, the algorithm will be framed, and it is going for processing, and we can able to get the output. So here the data is not labeled. So the purpose is clustering or association. That is, it is used to find all patterns. Suppose if you are having a cloth, we need to identify whether it is a cotton cloth, or it is a resin cloth, or it is a nylon cloth. So just like that, we need to study the pattern, and based upon the pattern, we need to group them. So it is mainly used for grouping of customers or cancer patients. So just like that are some of the examples of unsupervised learning. A real-time scenario for unsupervised learning. So no one is teaching the kid. So the kid is learning by its own, because it may fell down earlier. So depending upon that, it is putting some kind of pillows, and it is getting out of the bed. So it is based on the previous learning. It is doing all these things. So here, so this is an example for clustering. So here we are having some kind of raw data. So depending upon the raw data, based upon the pattern, what the machine is doing is it is dividing them into two different groups. So one group is said to be called as dog, and the other group is said to be called as cat. So depending upon the common properties, it is dividing them into two different groups. So this clustering is an unsupervised one. And the next kind of machine learning method is reinforcement learning. So here, what happens is we'll be having input raw data, and this is the environment, that is learning environment. If you are getting reward, we'll be moving in the forward direction. If it is not a reward, we need to correct it. So depending upon all these things, that is, it is nothing but learning by mistakes. If you are making a mistake, we need to come back and redo it again. Otherwise, if you are doing it in a right way, you just proceed. So in this case, we can able to find out the output. So here it works on interacting with the environment. So it is purposes for taking actions. So it will be used in robotics, aircraft control, business strategy planning. In all these cases, it is we are making use of reinforcement learning. Let me show you a small example. So what the dog is doing is the dog is trying to catch the ball, but it is falling down. So once it got the learning, suppose if we put our feet into the water, we have will be sink. So what it is doing is it is having a floating mat. So it entering into the floating mat, take the ball, and it is coming out. So based on the learning, it is finding the solution. So here it is getting a punishment, here it is getting a reward. So once you are getting a reward, we are moving in the right direction. Let me show you another example. So it is an iRobot. So here from this place the iRobot is moving. So here this is the right place. So when it is moving in the right direction, what happens is, so it is getting a reward. When it is moving in a wrong direction, it is getting a punishment. Okay, so if it is moving in a right direction, it is getting a positive marks. So here it is getting a positive mark. When it is moving in the wrong direction, it is getting a negative marks, that is reward is negative. So based on this, we can able to find out whether we are moving in the right direction or not. So machine learning, so this is all about machine learning. So machine learning, we are having three different types: supervised, unsupervised, and reinforcement learning. So based on these three things, we'll be having n number of tasks can be achieved with the help of this machine learning algorithms. And so these are some of the machine learning algorithms. Actually, it was given by TCS, and they are having some set of list of algorithms for machine learning. No one can able to have exposure in all the kinds of machine learning. So depending upon our need, we can choose the algorithm and we can employ it to the problem domain. Okay, so we are having n number of algorithms. So depending upon our need, we can choose and use them. And next, I'm going to have a brief intro about the research and research prospects in machine learning. So this slide, it actually shows the impact of research. So in 1956, IBM had produced a RAM. Uh, so the capacity of the RAM is 5 megabytes, that is 5 MB. So this is the size of the RAM, and this is the cost of the RAM. Okay, so imagine in 1956 we have spent this much amount of money for preparing 5 MB RAM, and in 2005 the size is reduced to this, and in 2014 the size is reduced to this. So here it is MB, here it is GB, and in February 2019 we are having 1 TB. Okay, so here its cost is $450 in in February 2019. Now it is approximately 200 US dollars. So when compared to this one, the cost is 266 percentage less. So this is the impact of research. So whenever we are doing research, it will be useful for mankind and it is less affordable. So trends in machine learning. So these are the different trends in machine learning. So here, depending upon the machine learning and its usage, so it is having dramatic increase, and everybody is investing in machine learning. So it is not specific for a particular domain. It is used by healthcare, it is used by automobile, it is used by manufacturing company, entertainment, agriculture. So all the top companies, Google, Apple, Facebook, Amazon, Microsoft, everyone is investing in machine learning to develop something new. And so these are the research prospects. So machine learning can be used to a variety of range of research problem areas. So in all these cases, machine learning will be very, very useful. Let me show a few. So in logistics, we'll be making use of drones and robots. So here, see how much they are investing on logistics. for making robotic applications for logistics. So here it is taking the mechanical options, and here it is taking the stock, here it is checking the reorder level. So everything is being done with the help of the robots. So in robots we'll be making use of machine learning algorithms. And now we are also making use of service robots also. So this is an iRobot. So it is used to clean the room. So it is also having reinforcement learning, as I mentioned earlier. It is identifying the direction and places to go with the help of reinforcement learning. And this is another thing. So here we'll be having Roomba and Brava Jet. So these two things are being connected by means of an input technology. So it will clean, it will put the mop options. And we can also have service robots. So it is helping in healthcare also. So it will assist the persons with disabilities. We can able making use of this service robots. So all these things also working on the machine learning algorithms. And in addition to this, it is also assisting the children with special needs. So here we'll be having a toy called as Leka. So this Leka, it is an exceptional toy. It is used by children with special needs. Suppose if the child is being affected by autism, it is making use of. It is a best companion. It'll ask questions. It'll give us emotion. It'll be a best companion for the children with special needs. And we will be also having autonomous robots. So we can able to put the delivery items, and the autonomous robot, they will go to the destination and they will deliver the products. And we can also make use of toys. So it is also a robot toy, so which can be used by kids also. So these are the examples of present day research working on autonomous robots. And the next thing is it can be used for disease diagnosis. So part A, so it is the one kind of machine learning technology which is used for identifying diseases in an accurate way. So pathology report. So that is what we call it as path AI. So this company's goal is to now they are working on reducing the errors and developing an optimized model for disease identification. And so as we all know, we are now being separated by this coronavirus. So we are finding the solutions, and every vaccinations, all the clinical trials are playing a major role. So everything happens with the help of, whenever a disease is coming, it has usually happened with a case of DNA damage. So here in this first case, we'll be having a DNA damage. So what happens is we'll be sending a PRP. So what it will do is it will attract NAD plus, and it has try to solve the DNA repair, and naturally it will heal it and it will solve the problem. So this is what it has given in the cycle. Okay, so here everything is being set in a proper way, and now the excess thing will be removed, and your DNA will work in a normal way. So this is what happens in the case of any kind of DNA damage, in the case of diseases. Okay, so here, so this medicine identification process, it will not come in a single step. So first you'll be having preclinical testing, then clinical research will be going on, next data analysis will be there, and they'll be going with the follow-ups. So here, in this clinical research, machine learning algorithms are playing a vital role to identify whether we are having a proper results or not. So it is learning in a proper way. And another thing is, whenever you'll be having a virus, it will come and join in your DNA, and it will usually affect the protein. So if the protein is folded in a proper way, the virus will not come and enter into your body. So another kind of research is going on in AI for protein folding. So how to fold the protein so that it will not be affected by any kind of virus. So here the shape of the protein makes it well, it is not vulnerable against the diseases. So here this AI is also influencing in protein folding. So we are having AlphaFold and the deep learning approach for identifying the protein folding aspects. And it is also making used in facial recognition. So federated learning, it enables them to identify facial recognition. it will be used in different airports and all. So we can able to identify the criminals easily with the help of this kind of federated learning models. And another thing is, it is something very very interesting, digital data forgetting using machine learning. So nowadays we are having enormous amount of data. So data is available in uh, enormous volume. So we need to store lot of data, and we are running out of places to store the data. So even though we are having big data and cloud computing, it is not at all suitable to forget least wanted data or unused data. So here, machine learning is also used for solving this kind of issues. So what it will do is, it will go and look into our data, and it will classify them into two groups, which one are frequently used and which are very least used and not used at all. So depending upon that, we can forget the unused data. So digital data forgetting is also playing a vital role, and it is also making use of machine learning algorithms. And the next one is, so here, now we are in a stage to preserve our planet. So here we are having a squishy robot jellyfish. So it will be entering into the ocean, deep into the ocean, and it will go to the coral reefs, and it will study. So it is called as a robo jellyfish. So it will study what is happening there, and it will develop a favorable environment where um, all the coral reefs will be preserved in a proper way. It will pass the information to the top, and it will have the base station, so that we can able to learn the changing environment with the help of this. And this one is published in August 2020. It is what we call it as slothbot. So it is just like an insect. It can able to monitor the insect, but it will look like just like an insect, so that it can we can able to have some kind of intelligent reports with this slothbot. And when we are going for a machine learning research, so usually we have, there will be difference between expectations as well as reality. So we used to have expectation like this. Sometimes the reality may happens like this. Okay, so when we are going for ML research, initially while starting the research, we'll be having lots of issues. So we could not able to identify what is happening over there. Everything will be like that. So the reason behind all these things is the complexity, uncertainty, dynamism in your changing problem environment, and we may have some kind of limited computational resources and the time to learn the environment, heuristics. All these things will be the factors that influencing for ML research, and if you are making use of them in a proper way, we could able to move in a forward. So this is the initial case. So when we are accepting them, we'll be moving like this. So when you are not ready to accept the change in a proper way, we'll go to this stage. If we are having a gradual acceptance, we can able to move forward, and we can able to work it in a proper way. So the concluding remarks. So what the kid is doing is, it is trying to drink the water, but it is not having a proper algorithm to learn it. So what this person is doing is, so the dog is uh, getting a stick out of a narrowed bridge. So it is learning the environment. Depending upon its learning, it is crossing its, it is doing its work in a proper way. So if you are not knowing anything, so just not get scared, but to learn. And the beautiful thing about learning is, no one can take it away from you. So machine learning, if you are learning it in a proper way and employing it in a proper way, it will be very much helpful as well as useful. And these are the references which I have referred for this presentation. And thank you for your patience listening. Thank you.
Thank you so much, ma'am, for your wonderful presentation. Uh, Thank you, participants. Thank you for your patience. and we will join after 10 minutes for our virtual conference closing ceremony. We will announce the best paper also that time, and I also have a great final duty of convey my thanks to all. So please be join with us. Thank you so much. Thank you, ma'am.
Thank you. Thank you.